Hello everyone, welcome to my presentation. Today I'm going to talk about thermal spray coating methods for ceramics. Okay, what am I going to talk about? First of all, what is thermal spray coating? After that, I'm going to talk about high velocity oxygen fuel coatings, flame spraying, plasma spraying, and lastly, I'm going to make a brief conclusion, and after that, my presentation will be over. So let's start with what is thermal spray coating. Thermal spraying consists of introducing particles in a thermal device where they are heated, melted, accelerated, and then projected onto substrate. So you can see here the progress in the images. Thermal spraying can realize ceramics or metallic coatings which do have not the same properties as a substrate. Thermal spraying can provide thick coatings. Approximately thickness range is 20 microns to several millimeters, and it can do that over a large area at high deposition rate as compared to other coating processes such as electroplating, physical and chemical vapor deposition. Coating materials available for thermal spraying include metals, alloys, ceramics, plastics, and composites. There are three main thermal spraying methods for ceramic coatings, which are flame spraying, plasma spraying, and high-velocity oxygen fuel coatings. So you can see here the common ceramic coating materials. For example, we can talk about alumina. Alumina is generally used for excellent electrical resistance and lower wear resistant hard and dense coatings, and titanium dioxide for resistance to abrasion and high temperature. For example, it could be used in gas turbines, and chromium for corrosion resistance, oxidation, abrasive wear resistant, smooth surface and hard coatings. And so let's talk about high velocity oxygen fuel coatings. This method is one of the newest of the thermal spray coating methods. This method uses high pressure oxygen and fuel gas, and the gases used are usually propane, propylene, and hydrogen. The burning gas mixtures reaches supersonic speeds, and the coating powder is fed into the flame. High-velocity oxygen fuel maximizes kinetic energy while minimizing thermal energy input. Thus, coatings with high bond strength, dense, and low porosity are obtained. Almost all metallic, ceramic, and ceramide materials can be sprayed with this method. In the method, the flame temperature can rise up to about 3000 degrees. Okay, but how it is work? In this method, fuel, which it could be a gas or liquid, and oxygen meets in a combustion room. At the same time, the powder material in the carrier nitrogen gas is sprayed into the combustion chamber. After all valves are closed, the gas mixture is ignited by an ignition plug. The explosion and shock waves that occur within a few milliseconds following the ignition, the dust particles temperatures rises close to the melting point and spray them onto the substrate at speed of approximately 800 to 1000 meters per second. This process happens repeatedly several times per second. Okay, the biggest feature of this method is that the surface of the main coated material at the same time of spraying does not exceed approximately 100 degrees. This method provides very high density and high bond strength coating. High velocity oxygen fuel coatings may be thick as 12 mm. It is typically used for deposit wear and corrosion resistant coatings on materials. such as ceramics and metallic layers. It can be used in the protective coating of gas turbines against different types of wear and high temperatures, and in parts of textile machinery, in rolling cylinders used in the steel, plastic, and paper industry, in the coating of cutting edges, and in the many parts of nuclear power plants. So let's look at the flame spraying. Flame spraying method is the oldest of the thermal spraying methods, and it's still the most used today. Flame spray guns can spray coating materials in the form of rods, wires, and powders. In this method, combustible gases are used as a heat source to melt the coating material. Generally, oxygen acetylene and oxygen hydrogen gas mixtures are used. So, in this method, the powder material is fed by effect of gravity from a feeder on the flame gun and transported to the nozzle of the gun to be collected and melted with help of carrier gas. Here the melted powders are sprayed onto substrate to form a coating. The flame spray process is simple and cheap method for thermal spraying. Compared to other methods, it utilizes lower temperatures and velocities, and thus producing a more porous coating with lower densities and adhesion strength. Flame spray can be used for all metals that melts below the flame temperature of 3000 to 4000 degrees. Okay, let's look at our last method, plasma spray method. Plasma spray uses electrical energy to create a plasma flame for heat input. In the method, an electrical arc is created between tungsten cathode and water-cooled copper anode. This arc ionizes the suitable gases and transforms them into plasma. This causes a very, very high heat input on the particles combined with high-velocity gas stream. There are two types of plasma spray, which they are atmospheric plasma spray and vacuum plasma spray. Vacuum plasma spray is performed with an absence of oxygen. This gives a coating with a lower amount of oxidation in addition to generally better coating properties. However, the vacuum is more expensive compared to atmospheric type. The plasma can reach temperatures up to 15,000 degrees, which is above the melting temperature for most of the materials known. With this method, oxide ceramics such as alumina, titanium dioxide, chromium, zirconium can be coated easily. The high degree of melting combined with a high velocity gives coatings with high density and high bond strength. Okay, let's make a brief conclusion. Thermal spraying is one of the most advanced hard-facing technologies for surface preparation and protection. The diversity of thermal spraying processes used for hard coating is due to a variety of applications and required properties as well as economical aspects. A systems analysis of the thermal spraying for hard-facing purposes shows common advantages like little restriction on the shape and materials of the component to be coated. The limitations are relatively low bond strength and degree of porosity. Okay, and these are my references for this presentation. Thanks for listening. The presentation is ended here.